Hello guys, this is Utsav, introducing Hindi text processing framework developed as a part of our IIT project. We have implemented all the functionalities that is needed for text processing framework like parsing, tokenization, sentence breaker, stop word detection, identifying variation, POS tagging, named entity recognition, and categorization. This is the web page we developed as a part of our project. It contains links to all the codes as well as description of each module along with the examples. Now, what we have been provided is some dataset from Hindi News Company. Let me show you the dataset first. So here is one sample of that dataset. Now you can see that this data is provided in the JSON format. It has keys like URL, text, language. So what we did is we passed this data and created one file for each kind of key. So let me run the code for this. So we have developed all the codes in a Python. So let me show you the output. So here you can see that for each key, one data file is created. We are mainly interested in the data file, text.data. Let me show you that data file. So as you can see, this file contains only Hindi text, bunch of paragraphs. We will be using this data for our further processing. Now let's move on to tokenization. Tokenization is breaking a stream of text into meaningful symbols. In our case, that is words. We have used NLTK toolkit, regex-based tokenization, as well as Indic tokenizer for tokenization. So let me display the demo of one of the tokenizer. So here it is. We are using expert data that we have created. We'll be storing it in output.data. Okay, our code is run. So you can see that it has created tokens for all the sentences, and each token has been kept in one line. Now moving on to sentence breaker. What sentence breaker does, it separates sentences from a paragraph of a text. In Hindi language, generally sentences are separated using the symbol called Purnaviram, which is denoted as a pipeline sign in computer. So let me run the code for this. Again, so here you can see it has separated it in bunch of sentences. Each sentence has been kept as one line. Now moving on to stop word detection. Stop words are most frequently occurring words in any language, and we have used this very simple approach for detecting stop words, that is finding out the most frequent words. So what we did is we went through complete corpus, denoted the frequency of each word, and then sorted them and found out the most frequent words. Uh, for detecting stop words, we require to run a code on a very large corpus, which is not feasible within this time frame. So what I am doing is I'm displaying you the stop words we have taken out as prior. So here you can see that It includes all the frequent words that occurs in a Hindi language. Adi, ityadi, apna, apne, ita, ine. Now, moving on to our next module, that is identifying variation. Identifying variation is an interesting problem in a way that it asks whether two words are phonetically similar despite of their different writings. So what it means that, so here I have we have provided very simple example. Champak and Champak, though they have written differently, they sound exactly similar. So for identifying this kind of variation, we have used two steps approach. We have first converted each word into the soundex code, and then we have translated that word into some English word and check whether these two words are synonyms of each other or not. If these two conditions are met, then it says that these two words are same variation of same word, and for that we have used the libraries from limiting, which is soundex and transliteration. Moving on to POS tagging. POS tagging is a process of assigning each word of a sentence a POS tag like noun, verb, adjective, etc. What challenge we face for POS tagging is resolving a lexical ambiguity. What do I mean by lexical ambiguity is many times we get words which can assign different kind of POS tag, and that POS tag depends on the context. So what we did is we did not assign POS tag solely based on the word but also based on the context. And for that we have implemented two probabilistic models, that is hidden Markov model and conditional random fields. Here in example we have assigned tags to words like Suraj is assigned noun, Kirana is assigned noun, Ab is assigned preposition. So what is HMM? HMM stands for Hidden Markov Model. It calculates, it finds out the base tag to a word by calculating the forward and backward probabilities of a text. In a simpler words, we applied this formula for each tag, and for whatever tag we get the highest probability, we assign that tag to a word. So what this probability means. First probability means that probability of a current tag given the previous tag. Second probability means probability of a future tag provided the current tag is this. And third probability means probability of word and tag occurring together. So let me run the code for POS tagger. So this code will take some time. Till that time, let me show the another POS tagger, that is CRF. CRF stands for conditional random fields. For developing conditional random field based POS tagger, we have used CRF++ toolkit. CRF++ toolkit takes template file as an input. Template file describes the number of features you want to use for a particular sequence labeling task. In this case, we have used total 5 features: current word, previous two words, as well as next two words, and we have considered all bigram features that is created by default by CRF. So the output for HMM POS tagger is prepared. We can see that it assigns noun tags correctly, but many a times it assigns preposition and other tags incorrectly. So that's why we have used CRF based POS tagger as an improvement to HMM based POS tagger. Let me show you the uh, accuracy for CRF based POS tagger. So it is, so sorry, let me first of all, okay, we have already created a model file for CRF based POS tagger. This model file has been created based on the template I just show you, and this model file has been run on larger corpus. So again I'm running the same file. So I am using this model file. Okay, tilde, and the same concept has been used for name entity recognition as well. We have used CRF++ toolkit with two different kind of template files. One template file uses the same feature as described in POS tag plus the POS tag assigned, And the another feature used is larger window